Ciao. Good morning, everyone. Hi. Thanks for coming. I think I'm the last one between you and your lunch. That happens often, so I'll try and not be too slow. So, hi, if you don't know me, I'm Daniel. Yeah, move here. Here. Can you still see me, or am I like... Yeah, okay. Oh, I see, right. Okay, sitting here. So I'm Daniel. I work in the Spring team. I focus on Spring security, so Spring security related projects, Spring security. I do authorization server, session, LDAP, these things. Here are my socials and email. That's the reason I'm here. You get to learn something and see some demos, but I'm here to, chat with you. So after the talk, come to me with questions, feedback, projects, anything, right? Chat with me. If you're too busy because you have too many things to watch, you can also find me on the internet. And if you're watching on YouTube, like, subscribe, and then send me an email. I'll take the time to answer your questions. I always like to learn about your specific problems. So we're going to be talking about passwordless applications and passkeys in detail. Before we get into the details of this, who here uses Spring, the Spring framework? Wow, that's like 95%. Like, who doesn't use Spring? 1, 2, 3, 4, 5. I'm sorry, the demos will be with Spring, but you get to learn some Passkey stuff too. So, passwordless apps. We all know passwords are bad. They get leaked. They are easy to guess or be stuffed and so on. So we don't want to do passwords. And we've been able to not do passwords to log in into our web apps for a long time. Who knows how we can do passwordless apps without like the modern, cool, fancy technologies? Any idea? Like it's 1998. And I promise you, you use this flow. Sometimes you do like privileged actions on a website without using a password. For example, when you forgot your password. You can request a new one by email. So we've been able to do passwordless apps for a very, very, very long time with email. And that's supported with Spring Security. So let's see, put this in presentation mode. I have an app that runs. Okay, perfect. And it looks like this. Localhost, let's put this one in big. 8080, right? So I can log in with a password here, Daniel, and the password is very secure. You will never be able to guess it. It's absolutely not a password. So if you want to turn this into something that you can log in without a password, the first thing you can do is enable this email flow. So in Spring Security, we have this security configuration where you say, oh, I want this to be public, private, so on, and I want to enable login with a form, a username and password. Now, since for the past 6 months, or a little bit more, we've had one-time token login. So Spring Security is able to generate a one-time token when you try to log in. So with this, you can configure it, and there's one thing you need to consider to configure is like, okay, Spring Security generates a token for the user. Your user experience is, how do I give that to the user so they can log in? So in here, you have to register a success handler. So when a token is generated, what do you do with it? So the first thing is probably maybe we put it in the console. Let's put a cookie, yeah, right? Got token plus... this is wrong, Monsieur IntelliJ. This is a OTT token. So OTT token, and you get a token value, right? Get token value. There we go. And so you give that to the user, and maybe you do other stuff. So we, by default, we redirect you to the page where you want to, where you can type this token. So we have a one-time token generation success handler, OTT handler equals new, redirect, blah, blah, blah. So when the user requests a token, we generate it, and then we redirect them to login OTT, which is the default page for typing the token. And so when you're doing these kind of experiences, right, you don't want to be printing this to the console, right? You want to be passing that through email. So I'm not going to do like an email flow here because it would take forever and it's complicated. So I have a fake email flow already implemented. So in here I could like mail notifier and then notify envelope got token, right? And then log in with the token plus the token value. And then we can also give a redirect address in the email, so there's only a click to do, right? You don't have to copy stuff around. So you go to login, OTT, token equals token value, right? And voila, you have 1998 passwordless login. We're done. You can leave now. So let's try it. Refreshes the page. Perfect. So we have a new field here. You can put your username, so it could be an email. In that case, it's just Daniel. And we're in focus mode, so I don't receive these little notifications for some reason. But can I tell it to give it to me? It doesn't show because I'm presenting, but you would see a thing that pops up. And so you get this token here. I can copy it, right? And then you can sign in. If I sign out, and if I try to log in with the same token, right, this doesn't work. Okay? So you can customize a bunch of things. You can make custom tokens. You can make, you can store these in different databases and so on. But this is 1998, and it's not super interesting. Yeah, you came here for cool things, for new things, for passkeys. Who knows what a passkey is? 3%, 5% of the room. Who actually uses passkeys today? 1, 2, 3, 4, 5, 6, right? Less than 10 people. So I think it's important to kind of show it. It's been showing up in the discourse. The big platforms have been trying to get you to use it. So here's my phone. We can see it. Here's you. Say hi. Hi. And so here's GitHub. I want to sign into GitHub. I click here. And then it tells me, put your username or your email address, put your password. So I would have to type my very long password or maybe use a password manager. Then I need a second factor and so on. Or I can go and click this sign in with a passkey. And when I do this, 1Password shows up because 1Password can save passkeys. If you don't have a password manager, the UI you would see on a Mac is this, right? On Windows, it would be Windows Hello. On Linux, I'm sorry, it's still, in the process of being baked. So there's this thing and says, do you want to use TouchID to log in with your username here, Kellen? And yes, I can. Here's my finger, right? I put it on the fingerprint reader. I don't know if we can see very well. Boop. And voila, I'm logged in. So this is one of the ways, right? I have a credential on this Mac to log in. I also have one in 1Password. So in here, sign in with a passkey. No, I don't want this dialog, my bad. Try again. Sign in with a passkey. I need to unlock this one and say I click sign in. So it uses a passkey. It doesn't use a password. There's also, you can have physical devices that are not biometric necessarily. So this is a Yubikey. It's a USB drive. I can plug it in. I can say sign in with a passkey. When I use the system to select, you can see the Yubikey is blinking. I click it. I have to put some sort of PIN or password in it so that if you steal my key, you cannot log into my GitHub. So this is one more way, right? And then the last way, my favorite one, is that I'm at a conference. I want to log in my GitHub, but I don't have my computer. With passkeys, I can sign in with my phone. So I can say, use this. Other options. So in here it says, can you sign in with iPhone, iPad, or Android device? Yes. Okay, continue. And then I get a QR code. Yeah. I can click here, sign in with a passkey. And so now it shows me a dialog on the phone. The phone connects to the computer over Bluetooth to be sure it's closed, that someone is not trying to hack me from across the world, from Paris, for example, where I come from. And then it says, do you want to log in? And I have to use FaceID. So I do continue. And then it's waiting for my face. Right? And we can log in. So that's the use case. And you can do it with your Google account. You can do it with your Amazon, your GitHub. Now, all the big providers are supporting this. It's supported in Keycloak out of the box. You can click a thing and say, I want my users to be able to log in with a passkey. So before we actually implement it, let's talk about what it is and how it works. So Passkey is a crypto credential. So instead of having a password that is short, I have a slightly longer thing, and I do cryptography with it, and I can log in. And so it's more secure than these plain text things that says like password 123 or admin 123. An authenticator, it's this. It's the phone, it's the Mac, it's 1Password if it's software, it's the Yubikey. Some of you may have heard of Fido. So Fido, it's not a dog, it's an alliance that makes specs, so the WebAuthN and the CTAP spec. CTAP is for the phone makers or the Yubikey makers, and WebAuthN is for you, for developers, to enable stuff in your browser. And there's a lot of people in the Fido Alliance, so Fido Alliance members, right? So originally it was, Google and Microsoft and so on. Now we have the security providers, 1Password, we have, Intel, we have Netflix, we have Sony, we have many, many people contributing to this. And so they make these specs. So for example, WebAuthN L3, this is the latest version of the W3C spec. It has all the trappings that you would expect of a W3C spec. So it has some code in it has some definitions, and it has 250 pages that you don't have to read because we do it for you. And we implement this so that it works with GitHub, it works with whatever, and you don't have to worry about it. How does it work? So how do Passkey work? They use crypto, asymmetric crypto. So basically, you have, hello, clicker, are you alive? Yes, there you go. On these devices, so on my Yubikey, on my phone, on my Mac, I have a private and public key pair to do authentication. So the way it works, for those who need a little refresher, we have Alice here. She generates a private key that she keeps private, right? That's in the name, and the public key that she can distribute. So in this case, she's going to give her private key, or her public key, not private, her public key to GitHub, right? And so in the future, Alice can prove that she owns the private key. She gets some content, and she can generate, using her private key, a signature of that content, and then she can send that content to github.com along with the signature. Then github.com takes the public key that matches the private key and then verifies that the signature is valid. And so github.com can authenticate and say, yes, this was generated by Alice. If an attacker tries to impersonate Alice, they don't have her private key because she kept it private. So they can generate a signature with another key, but it wouldn't match. And so here, github.com would reject the authentication, saying, wrong private keys. Think of it as wrong password, but more secure. And so with these public keys and private keys, you need to do two things. One, you need to generate them. So you need to register your device on the provider, the relying party in WebAuthN terms, that you want to log in against. So I log into GitHub, and then I go to register a passkey, and I click a button, and then some stuff happens, and a private key is generated on the device for this account, so for Alice, for github.com. It cannot be used anywhere else. And then a public key is generated, and we give the public key to GitHub. It puts it in their database linked to my account. And then in the future, we can use the public key, or we use the private key, we sign something, and then GitHub verifies the signature with the public key. Sound good? Nothing too crazy here. So in practice, what do you need to implement and what's actually happening, right? Signing is happening inside the device, inside the Yubikey. So let's look at one of the flows, so registration, when I want to add a passkey to my GitHub account. So if you go to the spec, you would see these beautiful diagrams that I love, and they're absolutely not confusing. They start at 0 in gray for some reason, and then you have to go like, and then you're happy. Okay, so that's too complicated. I think I prefer maybe a more schematic. What? Here we go. A more step-by-step way of doing it. So there are 4 things that interact when you're doing passkeys. Of course, there's you, the user, who wants to log in. There's the server, so in our example, github.com. And then you're interacting with github.com through your browser. So there's some sort of browser. And then the last bit is the authenticator. So it's the Yubikey, the password, the thing that does the crypto magic for you. So at some point, you go to GitHub, and then you click sign in with a passkey, and here the workflow starts, the registration flow. So you don't want to be signing in, you say, I want to add a passkey, click. The server is going to generate a random challenge. We don't really care about what it is, but the idea is that, I'm going to generate a signature. If someone copies that signature, sees it, they can't really reuse it, because every time I want to do a passkey action, a new thing will be signed. So that signature is sent, or that challenge, sorry, is sent to the browser. Your browser has JavaScript that calls credentials.create. So this is the WebAuthN spec that gives you this. You have a bunch of options you can pass in, but the important thing is that you use the challenge that the github.com or like your website, your backend created. When this function is called, this is where we have the dialog that comes up. So the authenticator then says, do you want to add a new passkey to your account? And so one important thing is most of the flows, you have to verify your identity. So for example, with my finger, I do the fingerprint, I do the Face ID. It's not required. Some passkeys may not have verification, but one thing is always verified, is that you are present and you are clicking on the thing. So the idea here is that a website cannot automate sending requests to your device to try and crack your private key. So when credentials create is created, the dialog comes up and then it waits for you to physically interact with the device. So you interact with it, maybe it's a simple click, maybe it's you put your PIN, maybe you put some biometrics, whatever, you do something with the authenticator. And then the authenticator says, okay, I'm sure you want to register a passkey for this website, so I'm going to generate a key pair, a private key and a public key. I'm going to store the private key and associate it with your account, so like, for example, Daniel, on the website that you're visiting, so on github.com. And that private key cannot be used for any other website. So it avoids a lot of phishing, cross-site attacks, and so on. I need new photos for the next. And then using that private key, it signs the challenge that was sent by the server. So then you do a little bit of JavaScript that takes the response of this credentials create, which is the signature and the public key, and we send it to the server. And then when you get there, the server takes the signature, the public key, and the known challenge and verify that the public key or the signature matches the public key, right? So we have the public key, the signature, the challenge. So the signature is the signed challenge. The server takes the public key, it verifies that the signature matches. So if it matches, it's probably a legit passkey registration, store it in the database. What you need to do as a developer is everything related to your backend and to your frontend. So you need to generate a challenge and store it in the user session. And when you get the response on the backend, you need to verify that the signature is correct. And it's a bit complicated to verify. We'll see that a little bit later on. And in the browser, basically, you need to prepare the data a little bit, massage it so it has the right shape, and then you pass it to credentials create. This is, trust me, this is blue. This is, yeah, well, okay. And then when you get the response, you send that to the browser. Okay? Everything else, this is not your problem. You don't program your users, and these devices, they're already built for you to do passkey signatures and so on. If you do authentication, so if you want to log in with a passkey, you don't need to change very much. It's the same type of flow with a few differences. So instead of calling credentials create, we call credentials.get because the private key already exists, right? We don't recreate a new one. When the authenticator validates that you really want to log in and it's actually you, instead of creating a private key, it will load the private key for github.com and then sign the challenge using the private key that existed already. And then we don't need to send the public key again because we suppose the website we're trying to authenticate against has our public key already. So we just send the signed challenge, we verify the signature in the end. If the signature is correct and matches a public key we know, we log the user in. Okay, cool. All right. Maybe one thing I want to reiterate, passkeys are not biometrics. Passkeys are not linked to my finger or my face or whatever, if I log in with your elbow or something. Passkeys, they're basically private keys with some metadata. They happen to be stored somewhere. So they could be a physical device, a Yubikey, they could be my phone, it can be my Mac, it can be your Windows computer. And you, as a user, you unlock that passkey vault, that passkey manager, using biometrics. So I use my face only to unlock my phone so that it signs challenges using the private keys that are stored inside. So my face has nothing to do with it. It's just kind of a password. When you think of, oh, passkeys are stored in 1Password doesn't have my face. Sometimes passkeys can be stored in the cloud. So if you have, so I'm in the Mac world here. If you have Mac, the private keys are synced to my iCloud account, so I can use them across devices. But it has nothing to do with biometrics. This is, Apple magic, the same way that you have a password manager and then they're shared across devices. Okay, enough talk. Let's do a little bit of code. So, passkeys. The first thing you want to do, of course, when you start a new thing and you will learn about it, is to go to Josh Long's favorite place on the internet, or at least the second one, which is docs.spring.io, right? Yeah. And we're doing Spring Security here because that's what we love, right? Ooh, yeah, here we go, Spring Security, amazing. So you go here, there's a beautiful search bar, and you can look for passkeys. There we go. And there's one dependency. So the first thing we tell you is you need one dependency, and it's this WebAuthN for J library, which is one of the 2 Java implementation you can use to actually do passkey signing, verification, and so on. So you need to put this in your project. And Spring Security Web. But you already have Spring Security because you're responsible professionals and you're protecting your Spring apps. So you use Spring Security. So in your build.gradle or in your POM or whatever you use in your ANT file, you add this dependency. Refresh the Gradle file. Once this is done, I'm going to restart the application. Is it downloading, you think? Okay, assuming it's here. Gonna restart, we'll see. Worst case, oh, there we go, finished importing, see? Okay, and then you restart this, and then you need to configure and say, I want my Spring application secured with Spring Security to have passkeys, so we do WebAuthN. WebAuthN is the spec for doing this passkey stuff, and we configure it. So you cannot do 0 configuration here, because there are some security considerations you need to take into account. So in here, you will put the RP name. This is your website name. So Spring Passkeys demo, right? You will put the RP ID. So this is the domain on which your app is running to ensure that your passkey cannot be used. So for example, that your github.com passkey, when I generate it, it's linked to github.com. It can only be used on github.com. So the passkeys I generate for this demo can only be used in localhost or subdomains of localhost. And then origins, again, protects against phishing, cross-domain attacks by pinning which specific hosts or which specific URLs these passkeys can be used on. And that's it, right? The basic integration is this. So if everything goes well, I can go to localhost 8080. Yeah, there we go. And we have a new button here, login with passkey. So I have not registered any passkey yet. So we can go log in here. Sure, username, password, amazing. And so I would like my users to be able to register a passkey, so I'm going to turn this on in the template index, or I guess, yeah, it's index. So passwordless demo, you're logged in, amazing. We put a link to the UI, the default UI that Spring Security gives you, which is WebAuthN register, auth B, yeah. And register a passkey with Spring Security. Okay, so here we go. It's refreshing. So we give you a default UI here, and so you can see there's no passkey linked to my account, so I can add one. So I'm going to use this Thetis passkey here, which is it's a security key, an external thing. Continue, and we can see. I guess I need to show you my where's this thing? It's here, right? So now the devices are blinking, so I can click this one. This one doesn't have a password. Okay, sure. And then it's registered. So now I can log out, and then I can sign in with a passkey. Oops, sorry, I clicked twice. I can sign in with a passkey. So again, it would start blinking, so I can click it, and then I can get logged in. And voila. So, fairly standard, easy. There's one little oversimplification we do here. One little lie. This stores your public keys in memory. So if I restart my app, oops, it's not great. So in May, in Spring Security 6.5, we will have JDBC support. So we will give you the abstractions to store your passkeys in a database. For now, you need to do that yourself. So if you're using the bleeding edge, our first implementation, so you need to add a few classes. I already have them, so I cheat. You have 2 repositories and a bunch of records that you put in those repositories. So those classes are the following. The user details, they're already what Spring Security uses to define a user. So my username, my birthday, my email, and so on. So this already exists. The 2 new things you need to do is this credential record table that contains basically the public key. This is where you store the public key that's going to be used in subsequent calls to authenticate you. And then you need to put a table to link users with passkeys, because maybe a user has multiple passkeys, right? I can register my Yubikey, but also I can register my phone, I can register my Mac, and so on. So these are the 2 things. This is a link table, so it's not super interesting. The credentials record details has more meat to it, so we can take a look in the code. That's maybe the sequel. So this credential record table, it needs to be linked to a user. So through the link table here, we have some sort of foreign key to the user. We have some data that we use for display. So when I go back to my website here, I log in with a passkey. Amazing. And then I go to register passkey, right? We have some dates, we have some names. So this is stored in these fields. These are not standards. This is Spring Security deciding this. And then 2 important passkey bits. So the credential ID is the unique identifier of the key. This way, when someone tries to log in, they send a signature. They also send, I'm signing it with key 123, so that we can look in our database and say, oh, this is key 123. Here's the public key for key 123. Try to log in. And then there's the attestation object. So the attestation object, I still see it in my nightmares. It looks like this. Oh my God. So this is from the spec, right? So this is all that comes back from either passkey registration this one is the registration flow. It has a few details. So it has a header that contains the signature in here. And then it has authenticator data, which is everything a website needs to know about the device that's used. And deep down inside, it has the credential public key. So the public key we care about. This thing is encoded with CBOR. Anybody knows what CBOR is? Yeah, complex binary object representation. Yes, one person. And so this is like in binary format. And then when you decode it, inside it has a KOSE key. So KOSE is like Jose, and the JSON object signing and encryption, but encoded with CBOR. So it has CBOR within your CBOR. Let's put some memes here. So very complicated. You don't want to be dealing with this. You just want to take it, store it. And then there's a bunch of other stuff that is basically extracted from the authenticator data. This is not needed, so you could drop that and not store those. But in the future, maybe you want to say, oh, can this thing be back up to the cloud? You may want to have rules around which passkeys are allowed. So we extract them since they're complicated to extract. We don't want you to let you deal with this. Instead, we do that. We give you this, and you can store it. All of this is generated or is extracted from the Passkey attestation, the big complicated thing, by WebAuthN for J. So when we look at the class that does the WebAuthN for J, the glue between Spring Security and WebAuthN for J, in the end, what we do, this one is the authenticate, right? And so in here somewhere, we have WebAuthN Manager. This is WebAuthN for J. It calls validate. Come on, there we go. Which calls verify, which calls verify, which calls parse, It reads the data, calls verify, which calls verify. Yeah. And then in here, it calls this gigantic method with step 1, 2, 3, 4, 5, and there's a bunch of verify. We verify many things. So this is why you don't want to be doing this yourself. It would take you forever, you would get it wrong, and it would not be secure. I think we have 25 steps or 27, I can't remember. 27 step in the authentication method. So you don't want to be doing that yourselves. Okay, so how long do we have? 15 minutes, that's good. So now we know how to do the default, UI for Spring Security. And, it's fine, we can register a Passkey. Maybe for internal tools, it's good enough. But when you're going to be doing user-facing stuff, you don't want your login page to look like this, right? You want a nice login page. So let's make a login page because it requires a little bit of work on your part. So the first thing we do is we're going to create a new template. So it's an HTML file, call it maybe custom login.html. Okay, it's called login, and it says h1 login, and then it has a button in it. That button will have an ID, Passkey login is fine. Sign in with a Passkey. Okay, and then we need to expose that page. So two things, I'm going to make a controller here, Passkeys controller, the basics. This is a controller. It has a get mapping, right? Let's call it custom login, right? This I want to return a template, so okay, Passkey login. And then in here we return custom login. So since we have Spring Security, this custom login page is secured, so you would need to be logged in to actually see it, which is not very convenient. So we make it public here, auth.requestmatchers, custom login, I think, right? Custom login dot permit all, right? And then maybe, if you're doing, you need to put your CSS, you need to put your 5 icon, whatever. Okay, so with this, we could have a new login page, I think, right? There we go, login. And so since you're doing this to delight your customers and put a cool UI, I'm going to show you that it's not because I do backend that I have no taste. So let's put some styling in here, very important. So the Passkey login button here will have some padding inside, 20 pegs, fine, and we'll have a background. That's the most important. And so in here, we're going to put a linear gradient, right, to top right, and then orange, and then aqua. That's I've been researching colors for a long time. Okay.
Sounds horrible.
No, that sounds perfect. You're wrong. There you go. There you go. Voila, voila. This is why you delight your customers, and maybe to ensure it's interactive, we do pointer cursor. Oh yeah, I forgot the Comic Sans. Well, I'm not sure it's deployed on every machine. So no, it's cursor pointer, right? Cursor pointer. So in my daytime, I do security, and then at night, I do beautiful UIs, right? So this doesn't do anything yet, which is normal if you remember our beautiful diagrams, this one here, right? We need to put a little bit of JavaScript in a browser so we can log in, actually do the thing when the button is clicked. So one way to do this would be to the WebAuthN spec, WebAuthN L3, and then in here, it's actually not terrible. If you don't read everything, just read the introduction. It's pretty simple. And so in here, you can say, oh, authentication, and here's some sample code. So you could start from the sample code. There's a lot of things here that says, like, send assertions to server for verification. So there's a lot of stuff that you actually need to do that's missing from the spec. So your developers, I don't think ChatGPT knows about this very well already. So we're going to use old school methods, and we're going to use the magic talent of copy paste. So I go to the default page, and I go to the source code that's shipped in here, and we have a WebAuthN.js. So this is us, Spring Security, we ship this. So WebAuthN core.js it's called, right? So it's basically a compiled version of this file. And what you care about is the authenticate method that's in here and its dependencies. So you can go grab anything that's up until, so here's authenticate. There's also a register method that you can steal. Take this, and then put it in a script tag, right? So this is text JavaScript, script, there we go. And then we put this here, this one, yep, okay. And then we're going to see, like the spec is all fine and dandy, but the truth is it's actually more complicated than what they tell you. And in here, we need to do a little bit of time leaf. So why? Because the authenticate method, we can call it, let's call it actually, and then we discuss the details. So in here, well, when the document add event listener, so when the document is ready, when I'm sure the button is here, we're going to attach an event listener to it. So document, find element or get element by ID, Passkey login it's called, beautiful. And then we add an event listener on click. So on click, we do an async function, takes the event if you care, doesn't really matter, and then you do stuff. And so in here, you want to authenticate. And authenticate takes headers, context path, and conditional mediations. Let's skip the headers. Context path is if your app is behind like /foo, and all your roots are behind /foo, you would put foo here, but empty is fine. And then conditional mediation is some Passkey black magic that we're gonna save for another day. So this is a async function, so I await for it. I await for the result, and it gives me a redirect URL. So when I'm logged in, I'm going to store the redirect URL, right? And then redirect the user. So window.location.href equals redirect URL. Okay. The headers here, what are these headers? Well, if you want to learn, you can go and look at the actual page. So in here, in the script, because we call that script too, here's the object, and it says X CSRF login, your nightmare, cross-site request forgery. Do not disable cross-site request forgery. This is wrong. Do it right. So with time leaf, you can extract those headers. So you can say in here, it's called _CSRef, get header name, right? And then the value of this is CSRef. So however you want to get your CSRF values, get them, put them in your headers here, and that's it. With this, if the gods of the demo are with us, custom login, so this pops up. We know this UI, so where's the air server? I'm not cheating, it's here, it's blinking, look. Can you hear that delightful click? And it fails, amazing. Probably some CSRF problems, or I went to the wrong page. Oh, it reloaded, didn't it? Okay, try again. Took, right, refresh, there we go. And are you up? Yes, you're up. Okay, great. Ah, yes, there we go. Okay, it fails. Promise. ID could not be converted to, well, I don't know. This is a failed demo, I'm sorry. In here, probably miscopied something. I don't know. Well, it is what it is. It failed. I'm going to stop. Try and debug it? No. I want to, but it's probably not the right time. I probably got something wrong, maybe in my headers here, token or something. But the main idea is you would get, so you can use a library, or you can use the code we provide. So it's Apache 2, you're allowed to use it. You don't have to redistribute it. And with that, maybe some observations in the end. Observations. So, complicated. See, I can't even get my demo right. If possible, let your identity provider do it. So if your identity provider is, I don't know, Azure Entra, then use Azure Entra and let it do your Passkey for you. If you use Keycloak, you can use the Keycloak there. If you really want to implement it, use a library. See, it's still complicated. Spring Security has support. In the next version, we'll have even better support. Please, please, please contribute. So you can go to github.com/springprojects/Spring Security. You can go to the issue tracker. You can find the WebAuthN related features, and you can go and upvote them so we know what you care about, what you want to use. And if you want to learn more about Passkeys and understand how it works, all the things you can do, you can go to Yubikey's website. I think that's the best resource I've found. So they will explain everything about, what's FIDO, how do Passkey work. So they will give you, the kind of diagram that I showed. And when you're doing implementation, there's WebAuthN here, which has a developer guide and has a bunch of, steps for telling you how to actually implement it if you want to go into the details. And with that, if I want to leave a little bit of time for questions, the repository is on Spring Security Passkey sample. The demo should work over there. And since you are security conscious professionals, you don't scan QR codes that strangers give you. This is the session, the feedback session. So please, take 5 seconds, rate the talk so I can know, what I need to improve next time. And socials, reach out, questions about Passkeys, questions about anything. I'll be glad to answer. And with that, thank you for your time. And let's take 3-4 minutes for questions. Thank you. Any questions from the audience? Yes. So the question is, how does it work if you lose your key? So one, that's why the key is protected by, a PIN or a password or some biometrics, so that if someone finds it, they can't use it just like this. So there's one thing you need to do is you need to go to the website and unregister the passkey for security. So you're going to go, and so in Spring Security here, oh, I'm logged in already. Well, whatever. Okay, in here you would go and have to delete it, which can be a problem because on my Windows Hello, on my 1Password, I can see the list of passkeys I have, and I can go and delete them. On a physical device like this, it's on me to remember what's on it, and so I have to go and delete them. Now, Yubikey themselves, of course, their business is selling those. So they tell you to get 2 of those, right? And then register 2 passkeys so that if you lose one, you can still log in with the other one. Their business is selling those. So maybe, maybe it has a link with this, but there's no great, revocation way of, doing stuff. But since it's crypto, since it's unique to the website you're using, there's less risk of stuffing credentials and attacking. Any other question? When do I let you go to lunch? I guess the answer is now. Thank you very much. See you at the conference. Bye-bye.